Landscape formation requires both endogenic and exogenic forces. The endogenic forces generally are driven by plate tectonics, which is going to amass new landforms. There's a bit of destruction, or quite a bit of destruction, actually, when we reintroduce matter into the asthenosphere. But that happens below the surface of our feet. So for this slide, we'll talk about what's happening on the surface for the landscape formation. So we're putting matter at the surface of the earth, and we are amassing large landforms like volcanic features, folded and faulted landscapes, which are traditional mountain forms. When we do that, we increase the elevation of those forms. And if you remember from early science classes, that we increase the potential energy of those environments. So with increased potential energy, we can transfer that into kinetic energy, and high elevations, as traditional theory holds, are areas of high erosion then, because of that high potential. So we've got high erosion, greater winds, greater ice, greater waterfall in high elevated environments. That means that as those environments are at liberty to erode, then gravity, wind, and water can then pull that material down to lower environments, which are generally areas where new land mass is built up. I say generally because low environments are also prone to erosion as well. So we've got these two characteristic locations sort of as a binary condition that we can think of. So if you consider the United States as a model, we've got high alpine environments with the Cascades, with the Sierra Nevadas, with the Rocky Mountains, the Appalachians, and the Ozarks. And those areas are going to erode material into low-lying areas. Kansas, Alabama, parts of Texas, and those then are where we're getting landscape buildup. The ultimate source of buildup is going to be at the margins or the edges of the continents, where rivers are empty into ocean bodies, or deltas and gulfs. So we get a significant amount of buildup in New Orleans, for instance, and in the Gulf of Mexico, because the Mississippi is such a large river, and it's shedding material from the Rocky Mountains and from the Appalachians over large geographic scales. The Mississippi River is the combination of the Ohio rivers and the Missouri rivers, and those rivers are the culmination of a lot of source rivers that are coming out of mountain environments. So we're going to deliver a lot of matter to the mouth of the Mississippi River, where we're building new landforms out into the Gulf of Mexico. This process is all known as geomorphology. So geo is earth, morph is to change, and ology is to study. So we're studying the morphing of the earth through different landforms, either destroying them or creating them. So all locations on earth are continually going through geomorphic change and process, some faster than others. The bottom first slide that's showing us a beach will allow recognition of morphology frequently with high and low tides. With storm events, we can see littoral waves remove matter and then redeposit matter further down a beachhead. So that's pretty easy to see. Slower areas of erosion then and redeposition then can occur inland, and then are more geographically isolated as suggested earlier. But overall, some areas easy to observe geomorphology, other areas you need a keen eye over many years to start to appreciate what's changing on a particular landscape. Ultimately, geography or geomorphology creates what you and I call topography, and that's the shape of the land that is the outcome of the combination of plate tectonics and geomorphology.